All right, biggest part, we've only got two more sections. We got 4.3, 4.4. Right triangle trig. So it's a lot of the same stuff that you did before. The only thing that's going to be different from whenever you were in geometry is that now you'll have all 6 instead of just 3. So whenever you were in geometry, you had right triangle trig, and we did sine, cosine, and tangent, whereas now we'll have cosecant, secant, and cotangent. So it doesn't change, like whenever we did, and we already talked about this a little bit, whenever we did SOHCAHTOA, it's the same stuff. So a lot of the same things that we've already talked about is really in this section. So whenever we have a right triangle, remember you have, whenever we do Pythagorean theorem, we have a squared plus b squared equals c squared. Okay. A and b are the short sides, and b is usually the length of the adjacent side. A is the one that's usually opposite, and then C is always the hypotenuse. That's never going to change. Okay? So when we did, when we had SOHCAHTOA, remember it was sine is equal to opposite over hypotenuse. Cosine is adjacent over hypotenuse. Tangent is opposite over adjacent. So whenever we do cosecant, it's just going to be hypotenuse over opposite. Whenever we do secant, it's going to be hypotenuse over the adjacent side, And then whenever we do cotangent, it's just the adjacent side over the opposite side. Okay, so none of that is really any different than what we've already talked about. So, bless you. If you need this here, that's exactly what we just talked about. Remember that the first part, this is just the so, that was the ka, and then this is just the toa. Okay, opposite over adjacent, and then just like it was before, we have just the reciprocal of its sister function. So remember, cosecant goes with sine, secant goes with cosine, and cotangent obviously will go with tangent. So whenever we find the value of each of the 6 trig functions of theta, so if we have, first off, we've got to make sure we have all 3 sides. Okay, so whenever we have A is 5, B is 12, we need to figure out what our third side is, what our missing side is. So in this case, we're missing the hypotenuse. So if we just use Pythagorean theorem, and remember if it's a squared plus b squared equals c squared, then I'm going to have 5 squared plus 12 squared equals c squared. Now on one like this is a special right triangle because it's going to be a nice, neat number. As far as like what our c value or what our hypotenuse value is, because it's going to be 25 plus 144 equals c squared, or 169 equals c squared. So what's the square root of 169? 13? Right. That's what I was thinking. Okay, so my hypotenuse is 13. Now once I have all 3 sides, then I can do my trig functions. Then I can basically take what is sine of theta, whatever my angle is. I don't know what my angle measurement is. We'll get there. Okay? But in this case, we'll have sine of theta. So what's opposite? What's opposite of theta? Opposite of theta is 5. Over the hypotenuse is going to be 13. Do the same thing for cosine. Do the same thing for tangent. So cosine is adjacent over hypotenuse, so 12 over 13. Tangent, opposite over adjacent, so 5 over 12. And then the sister functions, I'm just going to basically take, as long as I can make sure that I match up that I have cosecant of theta, I have secant of theta, and then I have cotangent of theta. All I have to do is just take the reciprocal of the sister function. So if its sine is 5 over 13, then cosecant is just going to be 13 over 5. If cosine of theta is 12 over 13, then cosecant is 13 over 12. And then the same way with cotangent and tangent, I'm going to have 12 over 5. What will happen, depending on what angle you have, okay, a large majority of these, the sister function will be bigger than 1. Okay? Because the hypotenuse is always going to be your longest side. So especially with with cosecant and secant, a lot of times, unless you have, those should always be numbers that are bigger than 1. If they're not, then we have some sort of issue somewhere. Tangent and cotangent are the only ones that could be opposite. It just depends on what angle you're looking at. Okay, if I'm up at the angle where angle B is, and I'm going, then my opposite and my adjacent angles change. Okay. So if we find the values of each of the 6 trig functions of theta, now in this case, what am I missing? I have the hypotenuse and I have the opposite side, so I'm missing the adjacent side. So if I'm missing the adjacent side, then I have, remember, it's a squared plus b squared equals c squared. So I'm going to take 1 squared plus b squared equals 3 squared. Okay? In some cases, you might not get a nice, neat number. That's okay. All right, so in this case, if I have b squared equal to, I'm going to go ahead and do a couple things at once. I'm going to have 9 minus 1. And then if I have b squared equal to 8, then I need to take the square root. Okay? 8's not a perfect square. That's okay, so I'm going to have a radical. That's going to happen every so often. So in doing that, whenever I break up the square root of 8, I'm going to have the square root of 4 times the square root of 2. So my b side length is 2 times the square root of 2. So once I have that, now I have all of my values that I need. So I can set up my trig ratio. So sine of theta, cosine of theta, tangent of theta. So sine is opposite over hypotenuse. So opposite of theta is going to be 1. Okay, so I'm going to have 1 over 3. Cosine, I'm going to deal with the adjacent side. So 2 square root of 2 all over 3. And then tangent is going to be opposite over adjacent. So I'm going to have 1 over 2 times the square root of 2. Now, I can't leave it as 1 over 2 times the square root of 2 because I can't leave a radical in the denominator, so I'm going to have to rationalize this. So, square root of 2 times the square root of 2. So I'm going to have the square root of 2 over 4. So then for my sister functions, all I'm going to do is take, so if it's cosecant, I'm going to take sine, and I'm just going to do the reciprocal. So the reciprocal of 1/3 is just going to be 3 over 1, or 3. Secant of theta is going to be 3 over 2 times the square root of 2. Okay? Again, I can't have a radical in the denominator. So then both the top and the bottom are going to get rationalized. So whenever I rationalize it, I'm going to have 3 times the square root of 2 over 4. Square root of 2 times square root of 2 is 2. Times 2 gives me the 4. I'll do the same thing then with cotangent, and I'll have 4 over square root of 2, and I'll have to rationalize that. Okay. Now, on one like this, if you pay attention that here is my original value, without rationalizing what's the reciprocal of 1 over 2 times the square root of 2? 2 times the square root of 2. So even if I rationalize it, if you don't see it, that's okay, and we end up with the square root of 2 over the square root of 2. We're going to end up with 2 times the square root of 2. Okay, so before we rationalize anything back with tangent of theta, okay, we started with 1 over 2 times the square root of 2. So that's really pretty easy just to flip upside down. Because what's going to happen is I'm going to end up with 4 times the square root of 2 over 2. This becomes a 2, that's a 1, and I'm back to the 2 times the square root of 2 anyway. Okay. The one that's circled over here is just the reciprocal here. You may or may not see it. If you don't, that's okay. If you do, great. And you just know, hey, I'm just going to flip it and I'm going to go on. Okay. I just want to stop there because we don't have, it's shortened day anyway. So let's just stop there. I'll put up the assignment and you can at least have part of it, and then we can do the rest of it on Monday.